Steps in a gravimetric analysis. After appropriate dissolution of the sample, the following steps should be followed for a successful gravimetric procedure. 1. Preparation of the solution. This may involve several steps including adjustment of the pH of the solution in order for the precipitate to occur quantitatively and get a precipitate of desired properties, removing interferences, adjusting the volume of the sample to suit the amount of precipitating agent to be added. 2. Precipitation. This requires addition of a precipitating agent solution to the sample solution. Upon addition of the first drops of the precipitating agent, supersaturation occurs, and then nucleation starts to occur where every few molecules of precipitate aggregate together forming a nucleus. At this point, addition of extra precipitating agent will either form new nuclei or will build up on existing nuclei to give a precipitate. This can be predicted by Weimarn ratio where, according to this relation, the particle size is inversely proportional to a quantity called the relative supersaturation where relative supersaturation equals Q(S). The Q is the concentration of reactants before precipitation. S is the solubility of precipitate in the medium from which it is being precipitated. Therefore, in order to get particle growth instead of further nucleation, we need to make the relative supersaturation ratio as small as possible. The optimum conditions for precipitation, which make the supersaturation low, are 1. Precipitation using dilute solutions to decrease Q. 2. Slow addition of precipitating agent to keep Q as low as possible. 3. Stirring the solution during addition of precipitating agent to avoid concentration sites and keep Q low. 4. Increase solubility by precipitation from hot solution. 5. Adjust the pH in order to increase S but not a too much increase as we do not want to lose precipitate by dissolution. 6. Usually add a little excess of the precipitating agent for quantitative precipitation and check for completeness of the precipitation. 3. Digestion of the precipitate. The precipitate is left hot below boiling for 30 min to 1 hour in order for the particles to be digested. Digestion involves dissolution of small particles and reprecipitation on larger ones, resulting in particle growth and better precipitate characteristics. This process is called Ostwald ripening. An important advantage of digestion is observed for colloidal precipitates where large amounts of adsorbed ions cover the huge area of the precipitate. Digestion forces the small colloidal particles to agglomerate, which decreases their surface area and thus adsorption. 4. Washing and filtering the precipitate. It is crucial to wash the precipitate very well in order to remove all adsorbed species which will add to weight of precipitate. One should be careful not to use too much water since part of the precipitate may be lost. Also, in case of colloidal precipitates, we should not use water as a washing solution since peptization would occur. In such situations, dilute nitric acid, ammonium nitrate, or dilute acetic acid may be used. Usually, it is a good practice to check for the presence of precipitating agent in the filtrate of the final washing solution. The presence of precipitating agent means that extra washing is required. Filtration should be done in an appropriate sized gouache or ignition filter paper. 5. Drying and ignition. After filtration, a gravimetric precipitate is heated until its mass becomes constant. Heating removes the solvent and any volatile species carried down with the precipitate. Some precipitates are also ignited to decompose the solid and form a compound of known composition. In drying we give usually 100 degrees C to 120 degrees C temperature. In ignition we give high temperature up to 3000 degrees C. 6. Weighing and calculation. When the precipitate is well dried we weight it. By the weight of the precipitate the amount concentration is calculated. This is the last step in gravimetric analysis. Subscribe our channel and click the bell icon for more videos. Thank you for watching.